Hi, this is the H rule with Devon and Grace. The H rule is A is used before consonant sounds, not just consonants.
Grace, I don't think that's what Miss Lawson wants us to be doing. I think that's the wrong H rule. Yeah, okay. Just go. Just go.
Okay, so this is the real H rule, the rule we're supposed to be doing, okay? This is the H rule in calculus. Alright, so the H rule in calculus is a way of finding the derivative, and we use the equation f prime x equals lim of h as h approaches 0 of f x plus h minus fx all over h.
Okay, so this is example 1, fx equals 3x squared. So the first thing you're going to do is you're going to plug in x plus h for the term, which is one term, and then you're going to have the minus 3x squared over h. So the first step, after you've plugged everything in, is you factor the x plus h and x plus h, which looks like this. So then limit as h approaches 0 is 3x squared plus 2xh plus h squared minus 3x squared over h. And then you're going to distribute the 3 at this front area. So that's going to be 3x squared plus 6xh plus 3h squared minus 3x squared over h. Then you're going to combine the like terms, which is the 3x squared and then minus 3x cubed squared, which gives you this, 6xh plus 3h squared over h. And then you're going to cancel h on bottom and top. So you're going to take this h out, and this is going to become 3h. So here we go. And once we've done that, because the h is no longer in the bottom, we can plug 0 in to this equation. And 0 for h just gives you 6x. So the derivative of this equation is 6x.
Example 2, fx equals x cubed plus 6x squared minus 12x plus 64. Alright guys, so the first thing we're going to do is we're going to plug in x plus h for these x's, and we're going to subtract the original equation from that and make it a limit as h approaches 0. That's going to look like that. So our next step is factoring these x plus h's, and we're going to end up with something looking like this. All right. And our next step is we are going to cancel like terms. So we're going to cancel the x cubed, the 6x squared, the 12x, and the 64 from this equation because you can cancel like terms. And that's going to look like this. So now we have lim as h approaches 0 of 3x squared h plus 3x h squared plus h cubed plus 12xh plus 6h squared minus 12h. And that is all over h. And because it's a fraction, we have an h on bottom and an h in the top equation. H is in all of the top equations. We can just cancel the h out of this entire thing. And that's going to look like this. So 3x squared plus 3xh plus h squared plus 12x plus 6h minus 12. And now we have lim as h approaches 0, so you can plug 0 in for these h's, and we are going to get 3x squared plus 0 plus 0 plus 12x plus 0 minus 12. And now we just add those together, and we get our final equation, the derivative, which is f prime x equals 3x squared plus 12x minus 12, QED. Lawson.
We'll work on French another time. Da-da-da.